Looking at graphing radical functions, we need to recall the domain of a function. So definition of domain of a function is the set of all inputs where there is a real output. So that means I'm able to input a value into my function and there will be a real output. For a square root function, the domain is determined by the expression under the radical. So we need to look at whatever is underneath this radical, and the expression must be greater than or equal to 0. So our first example of this, we're going to graph the radical function f of x equals the square root of x plus 3. But in order to do so, we first need to determine the domain. Whenever we're asked to determine the domain of a function that is in the variable x, what we are essentially asking ourselves is, what is x allowed to be? Because we're looking at a square root function, the expression under our radical cannot be negative. Therefore, it must be greater than or equal to 0. So that means x plus 3 has to literally be greater than or equal to 0. So we want to solve for x. That means x is greater than or equal to, and think about what we have to do with that 3 to have it moved away from x. So we need to subtract that, and 0 minus 3 gives us negative 3. So negative 3 is our starting value. So I'm going to establish a table of values here. So we're going to let x be negative 3. And we're going to notice f of x is equal to the square root of x plus 3. And remember, f of x just stands for y as a function of x. So if we let x be negative 3, do not forget your square root symbol. This is the square root of negative 3 plus 3, which is the square root of 0, which is defined and is a real number, 0. Now if we go to our next integer value for x of negative 2, we have the square root of negative 2 plus 3, which is the square root of 1, which is 1. Now we can let x be negative 1, but I want you to see what happens when we make that choice. We have the square root of negative 1 plus 3, which is the square root of 2, which is a real number, but it is also irrational. It is not an integer. It is about 1.4. So I do want to challenge you. Do you know what I could let x be in order to get an output of an integer value of 2? So if we go backwards and think about the fact, well, this is going to come from a square root. The square root of what is 2? And that would be the square root of 4. But this again comes from the square root of what? Plus 3, and that would be 1. So our input of 1 is going to give us an output of 2. And the reason I'm challenging you to do this is because integer values are so much easier to plot, aren't they, than irrational values. So same thought process here. What value of x do I need to choose to give me an output value of 3? So 3 comes from the square root of 9. So we need to think about the square root of what plus 3 gives us the square root of 9. And that would be 6. So 6 is a convenient value to choose to give us an integer value for y. So remember our graphing techniques. We need to label x. We need to label y. We need to show scale in all 4 directions. So All of these points are very close to the origin, so I'm going to go out 5 in each direction. And I'm going to start with my pivotal x value of -3, which was determined when we identified the domain. So -3, 0, -2, 1. I'm also going to plot -1, 1.4, 1, 2, and then 6, 3. So notice the beautiful pattern that we're drawing out from these 5 points. So connecting them smoothly, and then also realizing we chose to stop at x equals 6 because we had enough points, but this goes on forever. And that is addressed from making sure we understand x can be greater than or equal to -3. So your 2 questions. First question, determine the domain of f of x equals the square root of x minus 3. And you are asked to express this in interval notation. And your second question, determine the domain of f of x equals the square root of 3 minus x and express your answer in interval notation. And make sure you take time here. 3 minus x is not the same as x minus 3.